See, basically, the objective right now is to hide my data or copyrighted data to some name, to an image. Okay, if I look at this image, I'm telling you, if I look at this image, okay, see, this is a transparent image. What is the meaning of transparent is there is no background basically. So you don't see anything at the back. Okay, if I look at some of other images, if I go to my data folder or going to my data folder, if I open something like accounts, see, this is an image, has black background, it's black, it's not transparent. So in the image either you are going to see this as white or black. You basically do not have anything which is representing only this much of data. So this is called alpha non-transparent channel, where all the alpha values will be 255 values. For all the pixels, alpha is going to be 255. If you make alpha equal to 0 for any channel, that part is going to be transparent. So transparent in the sense, against the background you are going to see only that much of image. See, there is no background, it's not white, there is no background at all. So that's what we call an alpha. First thing we'll be doing for our project is we'll open something called alpha. Okay, I'll be reading an image, but IM read will differ right now. I'll be reading the image data, the map as well as the alpha channel. I'll return from here. Okay, before I proceed anything, I'll return so that I can only check this much. I'll select an image, say card image, right? Interesting thing is, if I say I am show RGB data, I am show RGB data, we are going to see the image. You see, it's not transparent. It will be always displayed with non-transparent background. Now how this image is rendered, if I just put alpha channel, you'll see this thing. That means only this much should be rendered, remaining all should be clipped off. So alpha is basically another image which will be either 0 or 1. Okay, but it's not binary image, it's same uint 8 array. So how the values are going to be, it's going to be 0 and 255 based on where exactly you do not want it to be non-transparent. See the values over here. Okay, it's 255, 255, 255, again it's going to be 0. So this basically represents where exactly the image intensity would be, what part. Okay, so good enough. See, what I'm now going to do is take this alpha channel into account. My main objective is to put my watermark inside alpha channel. So how am I going to put the watermark?
So what is map?
Pardon? Map is a color map, whether it's a HSV color map, RGB color map. So it's going to return how many colors will be there. So when you take map value, it's blank. So it will take default map. So in some of the images, it will specify the map. That means, so whether the image is between 0 to 100 or image is between 0 to 50 or image is between 50 to 100. So that explicitly you can specify in some of the images. I have a message. So what is my strategy? Look this thing carefully so you understand what way we are doing. Now, as you can see, I have separated my alpha channel from the image. This is my alpha channel. Alright, and this is nothing but a pixels like this. Okay. Now my first requirement is to put my message over here, but I'll be having different length of copyright data. It may be 2 bits, it may be 10 bytes, it may be 12 bytes. Okay. So first thing I want to do is I want to save the message over here. Okay. But you see, I do not want to disturb the transparency of the alpha channels. I do not want to disturb the transparency. So those pixels which are transparent will be 0. Those which you want to display will be 255. So obviously any PNG image will be 0 at the top. Okay, the image will mainly be centered across the middle. So I'll take the first value. Okay, so suppose my message length is, suppose it is hello. So its length is 5. So I have to store 5. But if I directly store 5, if the message length is 50, I'll be storing 50. At the receiver side, image will be displayed badly. I do not want that. So what I am going to do is, I am going to convert this 5 into binary. So what is my binary value? 101. But now, this is, I mean, every value will be of different length. Okay, I cannot afford that. So I am going to make them constant of 8 bits. This is now 8 bits. Okay, so what I am going to do is, here at the beginning, I am going to place 0. Then in the next pixel 0, next pixel 0, like that, 101. So all the pixels. And then I am going to take my pointer to the 9th pixel. This is my 9th pixel. Okay. I'll take first character, that is H. I'll convert this to ASCII. So 98 plus A, B, C, D, E, F, G, H. So 8 plus 8, that is going to be 106. Similarly, E, ASCII value. ASCII value of A is 98 plus 8
means 8.
Yeah. So E will be similarly 104. Okay. Similarly, L will be some value like that. Now I cannot put this 104 over here. Again the problem will be with transparencies. So what I am going to do is, again going to change this 104 into binary number. And then similarly the next one into binary number, next one into binary number, and adjust them all for 8 bits. And keep on placing those bits over here. Now,
so in 1 pixel we are keeping one value or
1 pixel, one binary bit.
One binary
bit. So I have filled the entire image with the binary bits.
Yes.
Now you see, you have seen image processing, value of 0 and value of 4, 1, it does not differ too much.
Yes.
Even if you put 1 over here, it is still transparent, because if you want to make it non-transparent, you have to make it 255.
Yes.
Okay. So once I have replaced binary values, this image transparency is absolutely similar to the parent image.
Yes.
Right. I am going to save this. Yes. Now the result is similar to your original image. Actually some ones and zeros are hidden over here.
Yes.
I do not have any information of them. Okay, because see, 1 is still transparent. If I had replaced 104, transparency would have got lost.
Yes.
So at the
more than 50% value.
More than 50% value. So at the receiver, I will be receiving this image. I have only one partial information. What? That first value, first 8 bits represents the length of the message. Isn't it? So I will be first reading first 8 bits. There will be set of ones and zeros. Convert them into decimal number. I will be getting message bits. Multiply 8 with that. So I will be getting totally how many bits are there? First 8 bits represent the message length. So I'll take that 8 bits, convert that to binary. I'll be getting some value like 5. So I know I have totally 5 message characters. Then how many bits I'll be having? 5 into 8. That is 40 bits. So from 9th pixel to 49th pixel, I'll read them. Totally 40 bits I'll read. Then I'll separate 8888 bits. I'll convert this binary number into decimal. What will be my result? 106, 104, 106, like that. Then if I call char function, There is again I am going to convert this ASCII value into character value. I am going to get my original copyright information back. So this is the logic I am using. I have a message, okay. For length of message, okay, I am adding 0 with this message. So what will happen is this will be converted into number. Message is basically characters. So A plus 0 means it will be giving 98. Now I will convert that into.
Sir, in suppose B रहा तो 0.
Which one?
Sir, suppose message B रहा.
B रहा तो it will be 99. C रहा तो 100.
Sir, इधर तो 0 ऐड करेंगे sir.
हाँ, so see, whenever you are taking 0 and adding any character, that character will be first converted into integer and will be added. So my fundamental thing is I want to get the ASCII code. So I am taking a number and adding the character with the number. Message is character format. So my result will be the ASCII code of that value. Okay. So that ASCII value I am going to convert that into binary. Okay. Once I have converted that into binary, I will be taking the rows and columns because I have to convert them into equal and binary symbols. So what I am going to do is I will be taking one row. One row represents one character. Till it.
Sir, what do you mean, sir? First row, ith row of all, the ith row of all.
No, I will not explain the meaning. This is already explained. You have to understand what is the meaning of it. Unless and until length of this one is 8-bit, I will keep on appending 0 with that. Okay. Store this in a temporary variable by name B. Why I should store it? Because BT will be of different length. Suppose there were 7 bits, I am appending 1 0. Now new symbol will be of 8 bit. I cannot make variable length array in Matlab. So I am going to save it in a separate array. I am going to allocate this array back to B. So right now B is nothing but, suppose I have 5 characters for hello. It will be an array of 5 rows. First row 8 binary bits representing age. Second one 8 binary bits representing E, like that. I do also want to store the length. For storing the length, I will be converting this n value into binary. Again I am going to make it of 8 bits length. Now in the alpha channel, in the first row, first 8 columns, I will put this value. That is binary equivalent of the length of the message. Then I will initiate my k. K means from where I will start hiding to 9. Because length of Bn is 8 now, it will be 9. P stands for the number of rows from which I will be starting. So I will be keep on looping through this message, add those message into 1 pixel. So of this alpha channel. After adding, increment the column value by 1. If column value is greater than number of columns, in case of bigger message, if column value is greater than number of columns, row will be incremented by 1. From next row again I will be starting. Then again if it cross, again I will be starting. So my pattern of storing the message is like this. This is my length. Then I will store up to this. I will come to next line. I will go up to this, come to next line, go up to this, come to next line, like this. Entire message has been stored now. After storing the message, I am going to save this data. Not only this data, as you have seen, this is not transparent data. Along with this data, I am going to add a channel alpha. Over there, I will also put this alpha value. What is my alpha value? Alpha value is actually transparent channel, but I have modified it with my watermarking data. Isn't it? It's encoded. Go to decoding. Ask the user to enter a file. First I have to know how many length is there. So interesting thing is, see, whenever you try to add ones and zeros, okay, into image pixel, by default it's going to be stored as 48 and 49. It's not going to be stored as number 1 and number 8. This is because of difference in double data type conversion and uint8 data type conversion. So what happens is, if I run this, you'll understand it in a better fashion. If I execute this one, give a car as input, my alpha channel is modified right now, right? Put the data. If you see this, you have the values 48 for 0 and 49 for 1. Okay, so at the receiver side, I do not want 48, 49. I want 1 and 0. So I'll subtract this value with 48. I'll be getting an array of 8 numbers. Convert that into string. Convert that string into a decimal number. So this n here is the length of my copyright information. Already I have read 8 bits. I must start reading from k equal to 9. As the logic I have used there, same logic I'll be using. I'll be reading 1 bit from 1 pixel of alpha channel, subtract 48, store it in B1 of J. Like that I'll read everything. After reading out, I'll be converting one row of B. Each row of B is now representing 1 character. I'll convert that into decimal number. After converting that into decimal number, finally if I call character code, that decimal will be converted into number. So if I execute this one, this is my result. So in the show return, observe what is my decimal. This is my decimal value. As and when I convert that into ASCII, it's going to be the result. But this is how this entire thing should work.
So this is decimal value.
This is decimal value. This is decimal equivalent value.
So how it converts character into decimal?
By adding 0. So you have done. So suppose A is equal to A. Okay. 0 plus S. 97 is added.
S is equal to 0 plus.
By adding a numeric value, integer value with a string, it will get converted into ASCII. So capital A starts from 62. Okay. Up to 98. Up to 88. Then there is a space, comma, colon. Like that. Then again from 97, lowercase letter starts. That's how it becomes.